Hey everyone, welcome back to the channel. My name is Rob, and in today's video I'm going to show you how to configure an IKEv2 IPSec client-to-site VPN where we're going to be using AnyConnect to connect to the VPN when we're done with this to test to make sure that it works. This is on Cisco iOS, not iOS XE, not ASA, plain old vanilla Cisco iOS. I'm actually going to be using this Cisco 2921 ISR Generation 2 router behind me. And with that being said, there are two things that I wanted to mention before I proceed with the video. The first thing is local authentication doesn't work. It does on Cisco iOS XE, but again, we're just using plain old vanilla Cisco iOS. That means that we have to use certificates. There is no other way, and I'm going to walk you through configuring the router to be a certificate authority, as well as issuing all of the certificates that you need to make sure that this works. Number two is the fact that split ACL doesn't work. So that access control list that you would normally create to define the interesting traffic that you want to traverse the VPN tunnel, that doesn't work. It's not taken into consideration when this is configured on Cisco iOS. So everything goes through the tunnel, even internet traffic. So if you're okay with those two things, then stay tuned and I'm going to show you how to get everything configured. I'm currently sitting on the console of the router that we'll be configuring. So we need to give this router network connectivity. And this part obviously is going to be different for you depending on how your network is set up and your IP addressing or your provider or whatever you have going on. So for me, this router is plugged into my network and it is on the 10.0.0/24 subnet. So I know that I can give it an IP address of 10.0. Actually, what am I talking about? It's not on the 10.0.0 subnet, it's on the 10.0.20/24 subnet. Knowing that, I know that I can safely give it a static IP of 10.0.2200 because I know that IP address is not in use. And I should be able to ping the gateway, which is 10.0.21. And there is success. I'm also going to stick IPNet outside on here because I'm going to test this with NAT when we're done. Once I VPN in to test this to make sure that everything works, I'm going to make sure that we have internet through the VPN tunnel as well. So we have do show run gig 00. We just have the IP address on there and then IPNet outside. And we need a default route. IP route quad 0 10.0.20.1. So now let me make sure I have internet. So I'll just try to ping 8.8.8.8 and we have a reply. Now that that is out of the way, we can get into the stuff that is pertains more to the IKEv2 configuration, and that would involve making sure the time is correct. We need the time to be correct because we are using certificates and the date and time has to be spot on. So I will say, first I'm going to give this a domain name. I'm going to say that the domain is cisco.lab. Then I'm going to tell it that we want to use a name server, and the name server will be 8.8.8.8. Let's make sure that works. Do ping google.com, get a reply. Now what I can do is say NTP server IP 1. Actually, you know what? If I just go with pool.ntp.org and it resolved the domain, And if I say do show NTP status, clock is synchronized. Do show clock. So we have the clock synchronized. Don't forget that you're using certificates. The clock and the time and date has to be synchronized. So far we've configured a host name, configured that interface for network connectivity, and then we configured the domain name, the name server, so that way we could resolve the network time protocol servers, and then made sure that the clock was synchronized. Moving on, and from this point forward, everything I do is going to pertain 100% to the IKE version 2 configuration. So we want to enable the AAA new model, so that way we can say AAA Authorization Network, and we will name it, because this is something that we're going to be referencing later in the IKE version 2 policy. We just want to create a name so that way we can tell it to look for this locally. So we'll say AAA Authorization Network IKE version 2 underscore group auth Z. Now you can name this whatever you want. This is just what I have here for this example. And then we want to say local. So when we reference this later in the IKE version 2 policy, it will know that IKEv2 underscore group underscore auth Z will be looking locally. Next, we want to enable the HTTP server. By issuing the IP HTTP server command. The reason for this is because we are going to be making this router a certificate authority. Basically, when we create a trust point to say that, hey, we trust this certificate authority, and then we want to enroll and be issued a certificate, we're going to use HTTP. So we're going to be doing this on the router itself, but using an IP address on one of the interfaces, which we'll just use gig00 since we've already configured that, and that will be the enrollment URL. You'll see what I'm talking about here in a second, but in order for this to work, we do need to have the HTTP server enabled and running. And next, we need to generate our first RSA Keypair. So we'll say crypto key generate RSA general keys modulus. We'll go with 2048-bit keys. If this is production, you might want to go with a little bit more than that. You want to make it exportable, and we are going to label it the same name that we are going to name the CA. So right after this, I'm going to start the configuration for the certificate authority, and I'm going to name that VPN CA. So knowing that in advance, I'm going to put a label on this as VPN underscore CA. Should just take a moment. Okay. Now we're going to move on to the CA configuration. And this is optional. You can make a directory if you go mkdir and say you wanted it to be flash and then the directory CA. I'll just go ahead. I'll just go ahead and do it, just to show you what's going on here. So we can essentially designate a directory for the CA certificates and files, and I'm going to. Oh, it already exists. So I must have already done this when I was testing things before, and it does. It goes CD CA. Okay, nothing in there. So that's good. So you can create a directory, and then in this next step, which I'm moving on to right now, configuring the CA, you can define that. So the next step would be crypto PKI server, and then the name of the certificate authority. I'm going to say that it is VPN CA. So I knew that in advance, which is why this label I also made VPN CA. Okay, then we want to say what this is going to be used for. So we'll say EKU server auth client auth. There's a bunch of stuff you can configure under here. This is, if I haven't mentioned it already, this is just a very bare bones configuration just to get you up and running with Ike version 2, by the way. So you can configure the lifetime, and which I highly recommend that you do, depending on what's going on with your infrastructure and your personal preferences. But I'm not going to configure all of that. Again, just the bare minimum just to get this working. Now, one thing that I will say to make this easy is grant auto. Otherwise, when we go to enroll for the certificate, that will essentially identify the server when we go to connect to this VPN. We'll have to go look at the certificate request and then manually grant it. If we put grant auto under the CA configuration, it'll just automatically grant it when we go to enroll. And like I was saying with that database URL, when we created the CA directory, we can say database URL /CA. Now, if you don't do this, it will be the default. So you don't have to do this. You don't have to create a directory. You don't have to direct it to another location if you don't want to. It makes it a little bit cleaner this way, but it's not mandatory. Now, important thing is no shut. Just like an interface, we want to say no shut, and this will start the certificate authority. It's going to ask us for a password to protect the keys, and I'm just going to put a very simple password of password. And it says certificate server enabled. You see that right here. And all should be good with the certificate authority configuration. Next, we're going to be creating a Trustpoint. So we want to say, hey, we trust this CA, so that way we can also enroll and get a certificate that we need for the server side identification, as well as the client as well. Towards the end of this, we'll issue another certificate that we're going to copy over to the computer that we'll be using to VPN in, and that will come from this certificate authority as well. So I'll start with crypto key. I'm a little bit all over the place with my typing because if I remember, I typically switch my keyboard out before I do these videos, because the one that I normally use, this, I don't know if you can hear the difference. This one's typically a little bit louder. All right, crypto key, generate, RSA, general keys. Again, modulus will be 2048, exportable, and then the label will be what we're going to define in our trust point. So we will say, well, you're going to see it in a second. When we configure the trust point right after this, we're going to say, hey, this is the RSA keypair that we want to use. I know in advance that that is going to be VPN server cert. Now, this label doesn't have to match the trust point name, because there is an option under the trust point configuration where you will define the RSA keypair. I've made it the same as what the trust point name is going to be, just to make it easier to understand. So we have the label VPN server cert. This entire configuration, as I'm doing it, will be listed on the website as well. So if you're having a little bit of trouble following along, or you would prefer to just read this, or maybe even copy and paste it into your own lab router, you can do that. Or at this point, if you want to open that up, it'll be in a link in the description, and you can bring that up and look at what it is that I'm doing, so that way you can kind of follow along and know what's coming up. Okay, so we created the RSA Keypair, and next we are going to create the Trustpoint. So crypto PKI Trustpoint, and I'm going to name it VPN Server Cert. Now remember when we enabled the HTTP server? This is where we will use that. We'll say enrollment URL HTTP, and then we'll use the interface that we configured on the IP address on gig 00. So that was 10.0.20.200. We'll start with subject name, and we will say common name, or CN, equals vpn.cisco.lab. Now, this isn't going to, in a production environment, this will or should match up. This isn't going to match up in this lab, because when I connect to the VPN to test it out, I'm not actually going to be using, I don't have, there's no DNS server that will resolve this vpn.cisco.lab. I'm going to be using the IP address, so we're going to get a warning saying that the certificate doesn't match. So just be aware of that. If we had a DNS record resolving this, then we would be fine. I'm putting this in there as the common name anyways, just to give you an idea of what or how it probably should be set up. So common name equals vpn.cisco.lab. Say the OU is IT, and then organization is RM Tech. How about that? Okay, and then revocation check, we'll just say none. And here is where we define this RSA Keypair. We say RSA Keypair, and we said the label is VPN Server Cert. And that is it. Now we need to authenticate. So we say crypto PKI authenticate, and the trust point is VPN Server Cert. It's going to ask us to accept this. If we want to accept it, we'll say yes. And then crypto PKI enroll, and again VPN Server Cert. It's going to ask us for a password again to protect the keys. Just type in password. And do we want to include the router serial number in the subject name? No, we don't. Do we want to include the IP address? No, not really. Do we want to request the certificate? Yes, we do. Since I stated that I wanted to automatically grant certificates under the certificate authority configuration, you see that we were automatically granted the certificate. So now if we say do show crypto PKI certificates, there we go. You see that we have the CA certificate as well as the one that we were just issued, as well as their associated trust points. All right, let's see. Enough dealing with certificates for now at this point. Except towards the end, we do have to create one more for the user. So this is going to be the pool of addresses that will be assigned or could be assigned to the host when you VPN in. And that pool is going to reside locally on this router. So I'll say IP local pool. I'll call it VPN pool. And I will say that this will be in the, we'll say 10.0.0.1 through 10.0.0.50. Okay, now we need an authorization policy, and under the authorization policy is where we will define this VPN pool. So crypto IKEv2 authorization policy and I will name it IKEv2 underscore auth z policy. Whoops, didn't mean to do that. So we'll say pool, VPN pool. Now, here is where you can do a lot of other stuff as well. You can set the default domain name. So set default domain to send to the client. You'll probably want to configure that in production. This is where you would configure split ACL, but like I mentioned, that doesn't work on Cisco iOS, unfortunately. And all of this other stuff in here. We are just using this to define the VPN pool, or should I say the local pool of IP addresses to be dished out to the clients. And again, this is a very bare bones basic configuration. So this is really all I need to do right now. I do recommend that you check this out, kind of play around with it, and see what else you might be able to configure underneath this authorization policy. If we issue the do show run pipe section, crypto PKI, should I say crypto IKE version 2, we see that this is all we have. Crypto IKE version 2 authorization policy, IKEv2 underscore auth z underscore policy, and define that pool that we configured right here. Okay, moving forward, we need to have a proposal. This is where we say, hey, here's what we can do. Here's the crypto we can do. Here's the hashing, the Diffie-Hellman group, and all of that stuff. This should exist by default, but I found that it seems to not sometimes. So I'm going to make sure that it does by saying crypto IKE version 2 proposal default. I just go over this, make sure that it's configured just in case it's not, and it's one less thing to worry about down the line. So we'll just say encryption, AES, CBC 256, AES, CBC, say 192, integrity, SHA 512, SHA, I think it's 384, and then for the Diffie-Hellman group, we'll say group 21, 20, 14, 19. Okay, do show run pipe section crypto IKE version 2 proposal default, and this is what our proposal looks like. In production, you might get past the default proposal and end up with multiple different proposals with different configurations. But for this example, the default works just fine. Then we'll move on to say crypto IKE version 2 policy default. Now this, I believe, does exist, but again, just to make sure, we want to tell it the proposal is the default. And it looks like that's the way that it was. So do show run pipe section IKE version 2 policy, and we just see that we have match FVRF any, and then proposal default. These are both default configuration parameters. Okay, now we need to create a certificate map. The certificate map will be linked in the IKE version 2 policy, or should I say the IKE version 2 profile. And this is where we can say, hey, this is where we can say, hey, this is the IKE version 2 profile that we want to link up with. And there's a whole bunch of different stuff you can do. We're using certificates, so we can say, here's what to look for in the certificate. And that would be one way to classify this. And to do that, we'll say crypto PKI certificate map, and we'll call it cert map. Give it a line of 10. And the way we're going to match this certificate, and we still have yet to create and export the certificate for the client, but the way that we're going to classify this is we want to look for the issuer name. We want to see if it contains, for the common name, we want to see if it was issued by RCA. So it should be common name equals VPN underscore CA. So this is looking for, so when the client sends the certificate to identify itself, if it came from, if it was issued by VPN CA, it's going to fall under our IKEv2 profile that we're going to create next, where we're going to reference this certificate map. Okay, so we'll say crypto IKEv2 profile, and we'll name the profile crypto IKEv2 profile, yeah, and we'll name it IKEv2 underscore profile. It's nice and generic. And the first thing is we'll match that certificate map. So we'll say match certificate, and we will put in the name of our certificate map. Okay. Authentication, remote. Now you can do a bunch of different things here. You can use AnyConnect EAP, and you can identify the string that AnyConnect will use by default. You can do a bunch of other stuff, pre-share, etc. But what we are doing is we are using certificates. So we say RSA-sig, the RSA signature, and the same thing with the local authentication. So authentication local RSA sig. Okay. Now PKI Trustpoint. Remember that Trustpoint we configured? I believe it was called VPN server cert. We want to tell this profile that that is the Trustpoint that we want to use. So let's scroll back up, and yes, that is what it's called. So I'll just highlight this and right click to paste it in there. So we have a PKI Trustpoint VPN server cert. Now at the very beginning, when we enable the AAA new model, remember when we went AAA Authorization Network IKEv2 Group AuthZ Local? This is where we're going to define that, as well as our authorization policy as well. So what we do is we say AAA Authorization Group, and then we want to say cert for certificate, and then the list will be, we start with that AAA group, and then we reference the authorization policy. So the AAA list name was, there we go. The AAA list name was IKEv2 Group AuthZ. Paste that there. Not the local. I accidentally caught that in there. And then the name of the authorization policy, which was this right here. So we have crypto IKEv2 authorization policy, IKEv2 AuthZ policy. Okay. And then we want to say that we want this to use a virtual template 1. So we're going to be using virtual templates, and the virtual template will be configured the same as an interface, except it'll be used as a template to create a virtual access interface anytime a user VPNs in. Just to give you a brief overview of what we just configured, I'll issue the do show run pipe section crypto IKEv2 profile command. So here is our IKEv2 profile. We match the certificate map, where in the certificate map we want to look out for certificates that were issued by VPN CA. And then for both local and remote authentication, we want to use the RSA signature. The Trustpoint is VPN server cert, and then where we define the AAA list and the authorization policy, and then our virtual template. All right, and that is all there is to do there. Now we need to create an IPSec profile where we just define the IKEv2 profile, essentially. Crypto IPSec profile, and we will call it IPSec profile. Set IKEv2 profile, IKEv2 profile. That's that there. And now what I'm going to do is create a loopback. The reason for the loopback is because on the virtual template, we're going to use IP unnumbered. We want to borrow an IP address. Now, I could probably do IP unnumbered and then gig 00. I think it's more common to use a loopback. But for that loopback, I will just give it an arbitrary IP address of 172.16.1.1 with a /32 mask. And then onto the virtual template configuration. So we'll say interface virtual template, and we need to say virtual template 1, and then type is going to be tunnel. Now, if anybody is familiar with GRE tunnels and IPSec, and then under the tunnel interface for GRE, using the tunnel protection command, this is pretty much the same thing. But first, we want to say IP unnumbered and say we want to borrow that IP from loopback 0. I'm going to set the MTU to 1400 for the additional overhead. Those additional layers of transport layers, those additional headers that'll be tacked on when data traverses the tunnel. And with that being said, I'm going to clamp the maximum segment size as well. So I'll say IP TCP adjust MSS, and I'll say 1360, which is 40 bytes less than the what we set the MTU. The tunnel mode is going to be IPSec IPv4. Now remember, this virtual template is just a template. Everything we put in here is going to be applied to the virtual access interface when we VPN in. Okay, so last but not least, we want to say tunnel protection IPSec profile, and then IPSec profile, where we define the IPSec profile, which called on the IKEv2 profile. And we see that ISACamp is turned on. Alright, so we're done with IKEv2 config. The bare bones, bare minimum that we have to do to make this work, except that we need to now have a certificate for the user. So our test user that we're going to use to VPN into this needs a certificate. So we need to essentially do what we did at the beginning with the VPN server cert, but I'm going to make another trust point called VPN user cert. And first, I need to make sure that it's exportable and that the keys are 2048 bits. So I'll say crypto key generate RSA general keys modulus 2048 exportable. Now you need to make sure that this is set as exportable, because if you don't, you're going to wonder why you can't export the certificate, either to a USB or TFTP or whatever you're using, you need to make sure that you define that it's exportable. And then we'll say the label is VPN user cert. Wait for that to generate the RSA keys. And we'll move into the Trustpoint configuration for this user certificate. So PKI Trustpoint, we're going to call the Trustpoint VPN user cert as well. Enrollment URL HTTP 10.0.20.200, just like for VPN server cert. Subject name, we'll say the common name is VPN user cert. Revocation check, none. And RSA Keypair, we need to make sure that this matches up. And again, the label you put on this doesn't need to match the name of the trust point. We could have put anything right here, and then you can define it under the using the RSA Keypair command. Okay, and then again, just like before, crypto PKI authenticate, VPN user cert, crypto PKI enroll, VPN user cert. Give it a simple password of password. Do we want to include the router serial number? Nope. IP address? Nope. Do we want to request the certificate? Yes. We should automatically be granted the certificate, and we were. And now is where we need to export the certificate. So you can do this a couple of different ways. I can actually TFTP it because this router I'm doing this configuration on is connected to my network. Also connected to my network is a TFTP server. You might be in a position to want to use a USB drive or something like that, but either way, the command will be, the gist of it is exactly the same. It just depends on what protocol you're using to transfer it or what kind of physical media you're using. So I'll go ahead and show you. The command is crypto PKI export, and we want to export the VPN user cert, and we want to tell it that we want to use PKCS12. And here is where, if you're using USB, you could say USB. I believe USB is in there. Unless USB doesn't pop. Am I just not seeing it? USB may not pop up unless the drive isn't. So does this router have a USB? Yeah, it has two of them. Okay. It may not pop up unless the USB drive is inserted, but I'm certain you can use USB. And if that was the case, you would tell it USB, and then, you know, over it was USB 0. I think you get the general idea. I'm going to be using TFTP since that's most convenient. So I'll say crypto PKI export VPN user cert PKCS12 TFTP, and my TFTP server is 10.0.20.10. And the name will be VPN user cert.pfx. Now this is going to export the entire chain. So you're going to get the CA certificate as well as this VPN user cert certificate as well. And so you don't have to worry about doing the exporting the CA certificate separately. So that way the certificate from this router is automatically trusted. This is going to do it all in one. We need a password, and we need a passphrase. So we'll go password. The host is correct. We put that in there previously, 10.0.20.10. That is my TFTP server, and the destination file name, VPN user cert.pfx. Should work. Okay. Whew, I was getting a little nervous there for a second. Let me make sure that that transferred over. So let me go to my TFTP directory, ignore everything else in here, but here it is, VPN user cert. All right, we're still not done with this router yet. Very important, you have to zeroize and get rid of the Trustpoint. You have to get rid of any little part of this certificate that we just created for this user. So otherwise it won't connect. If we issue do show crypto PKI certificates, we're going to see that now we have 3 certificates, and it is right here. This very top one is the VPN user cert. We want to zeroize the key by issuing the command crypto key zeroize. What am I doing? Crypto key zeroize. Okay, there we go. RSA and then VPN user cert. Yes. And no crypto PKI Trustpoint VPN user cert. Yep, we want to do this. We are sure. Then we'll also issue the command no crypto IKEv2 HTTP URL cert, as well as turning off the HTTP server since we don't need it anymore. And no IP HTTP secure server either. And then when we disabled the HTTP server, I mean, unless you HTTP and use HTTP to access the router anyways, otherwise probably disable it from a security standpoint. But when we do that, it automatically disables the certificate authority server because it's relying on the HTTP server to be running so that way it can issue certificates. Now we are complete. Actually, no, I have to go back and finish the NAT configuration. So far we just configured the IP NAT outside on gig 00. I'll come back to this in a second. First, I want to get this set up on the computer. I want to connect to the VPN to test it to make sure that it works. Once you're on your computer that you're going to use to connect to the VPN and use Cisco AnyConnect on, you want to download AnyConnect. Now, I don't know if I can post the download because I don't want to piss off Cisco. I don't know if that's a thing where they're going to be upset with that. I'm not going to post the download link. I believe you need a Cisco contract to download it. However, if you can't find it anywhere and you really need to have it because you're trying to get this working, send me an email and I'll see if I can help you out. How's that? Is that fair enough? My email will be in a link in the description of this video, by the way. I have already downloaded AnyConnect. I have already installed AnyConnect. I told myself before I made this video that I was going to wipe it out so I could do everything from what it would look like from complete scratch, but I didn't. So the installation's straightforward. You double click it and you go through and you install it. There's really nothing advanced about the installation. Of course, this is giving me a bunch of options because it's already installed, so it wants to know if I want to remove it, repair it, or modify it. So we'll just pretend like it's not installed, and I went next, 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 and then now, okay, AnyConnect is installed, so we're all good there. See? All good, installed. There are a few things that we need to tweak. Actually, one of them is the fact that I need to get rid of... See, this computer is already set up for VPNing into my company. So I'm just going to I'm going to get rid of that certificate really quick that already exists. I think that if I don't, then it is going to be a conflict with the certificate that I'm going to add for this lab. And I think it's under local computer, personal certificates. Yeah. So I'll get rid of the certificate. I'll install it again later to make sure I can still VPN into my work stuff. Alright, I just want it to be nice and clean. Okay, so we installed AnyConnect. There's a couple tweaks we need to do, but first, I want to make sure that we get that certificate installed. Remember the one that we created, VPN user cert, and then we exported it via TFTP, and I brought it up now on my TFTP server. All you do is double-click it in Windows. I've had a problem with putting it under the current user. It gives me an error, something along the lines of this certificate is not meant for this purpose, for identification or something like that. All I know is that putting it under local machine seems to have solved that problem, and that's what I'm going to do. Everything else it's going to figure out automatically. And I'll go ahead and just say that, sure, okay, we'll mark the private key exportable, and then we need to put in the password that we set when we exported this. And then we'll automatically select the certificate store based on the type of certificate. Alright, it's imported. Let me bring up my certificate console here and just show you really quick what happened. So it automatically stuck the certificate under certificates for the local computer under the personal certificate store, and here's our certificate. What am I looking for? There we go. So we have the private key, and we see subject vpn.cisco.lab. And like I mentioned when I was exporting this, that it is the certificate chain. If we go under trusted root certification authorities, we will see that we should have VPN. There we go. VPN_CA. And now we need to open up our File Explorer and go to our C drive or wherever you install your programs, and go to Program Data. So we have C drive, Program Data, go to the Cisco directory, go to Cisco AnyConnect Secure Mobility Client, and the first file we want to modify is AnyConnect Local Policy. Now you're probably noticing that in my folder I have these two files. That's because I've already modified them for my work VPN, and that way if I have another computer that I need to install this on, I can just drag these over really quick. But what you want to do is go to AnyConnect Local Policy and click Edit. Look for Bypass Downloader and set it to true. It should be false by default. Go in there and get rid of that and put true. Now, once you do that, most likely you're going to click Save, and then it's not going to have permissions to write that in that directory. The best way to do it is to copy it out. So I'll just copy it from here to my desktop and edit it. I'm going to put in true, save it, and then copy it back. And then it's going to prompt me to elevate the permissions to administrator. And then it should go. All right, once that's done, click on Profile, and this will most likely not be there by default. It's there because, again, like I said, I already had AnyConnect installed. And I will actually, so you have a template for this. I will put, I'll put one in the downloads, so you can download it. You can download it and then copy it over. Anyways, we'll pretend that we'll pretend like this one isn't here. Actually, we'll delete it. We're gonna pretend like we just downloaded it from the rmtechcentral.com website, and we downloaded it to our desktop. So we right-click this, and we want to change just two things. First, and this is set up for, again, my work VPN, but we want to change this to the address. Now, again, we're going to get a certificate warning, like I already mentioned, because we're not using that vpn.cisco.lab domain name, which is in the certificate. We're going to use the IP address. So here I'll put 10.0.20.200, which is the address on the router's gig 00 interface. For a host name, and this is what's going to pop up in the AnyConnect list of hosts, I'm going to change this to Cisco Lab Router. Last thing, auth method during IKE negotiation. This is normally AnyConnect EAP by default. You don't want it to be AnyConnect EAP by default if you're using this method, so it will be IKE RSA. Let's save this file and move it on over. All right, let's go ahead and open up AnyConnect. Now, since this was set up before, the last name I had in there for my personal VPN is going to still exist, but we see that we have the Cisco Lab Router in there as well. And I didn't realize it was going to attempt a connection as soon as I clicked it. It's probably going to fail right off the bat because we are going to have an issue with the certificate. Like I mentioned before, this is only popping up because it can't verify the server because it's looking for vpn.cisco.lab. We have 10.0.20.200 in here. So we need to change a setting to not block connections from untrusted servers. Once we do that, now if everything's fine and the certificate matches up and everything like that, you won't have to do this, but we do have to do this in this case. It'll probably still pop up and warn us about the certificate, but after we choose to allow it, everything should be good. And here we go. We're going to say, see right here it says certificate does not match the server name, like I keep mentioning, and we will connect anyway. And there we go. We should be able to ping that loopback. Go show run interface LO0. That loopback we created, 172.16.1.1. That should give us confirmation that we do indeed have a connection. And we do. Let me go back to the router really quick. And one thing that I should have mentioned under the authorization policy, so if I issue show run pipe section crypto IKE version 2 auth, where we define the VPN pool, we probably want to give it a DNS server. And we can. Back when I was mentioning that we can configure a bunch of other things under here, and I just configured the VPN pool, configuring DNS is most likely something that you want to do. So we'll just say DNS, and we're not going to be... actually, you know what? I can say... Yeah, why not? I'll just use my internal DNS server, since this is piped back through my internal network. So I'll say 10.0.20.13. Next time we connect, we'll be assigned this as our DNS server. And then let me complete the NAT configuration so I can make sure that we actually have internet working. It won't reach out to the internet because we don't have NAT configured. So let's complete the NAT configuration. First, I'm going to disconnect from the VPN. So that way I actually have access to that virtual template interface. Otherwise it locks me out of it. So I go interface virtual template 1, IPNAT inside, and then let me create my NAT access control list. I'll say IP access list extended NAT permit IP, and I will say 10.0.0.0. I believe that is the IP pool. And since this is 1 through 50, I could try to summarize that, but I'll just say it's a /24 for now. So I'll say wildcard mask will be 0.0.0.255 to any. So that's going to say any host with an address in this network will be permitted to be translated. The command to complete it would be ipnat inside source list nat interface gig 00 overload. Let's connect to the VPN once more and see if we get our DNS server and see if we have internet access since we configured network address translation. Okay, there's a certificate warning again. We're going to connect anyway. And we are connected. Let me go back to my command prompt and issue an ipconfig/all. Just want to make sure that we got that DNS server. And there we go. So we have the IP address of 10.0.0.3, the DNS server 10.0.20.13, and now that we configured NAT for our VPN traffic, we should have full reachability out to the internet. And we do. Now let's just verify that it's going through the tunnel, and I will use the traceroute command. And we'll just, we're just mainly looking for the first hop, which will be that loopback, because as soon as the traffic gets over to this router, it's de-encapsulated and an ICMP time to live exceeded message is sent back. It will be sourced from that loopback, since the virtual template is borrowing an IP address from the loopback. So we know that the first hop is supposedly the loopback address. We know that the traffic is going through the tunnel. And there you go. That is how you configure a bare bones IKEv2 VPN on a Cisco iOS router. So I hope that you enjoyed this video. I really hope that you learned something. The video ran a little bit longer than I intended, but that's what happens with these things sometimes. Anyways, if you have any questions, feel free to reach out, leave a comment in the comment section below, or you can email me directly. Send an email to rob@rmtechcentral.com. Anyways, thanks once again for watching this video, and I'll see you on the next one.